everyone, welcome back to another Leetcode video. And so today we're going to be solving climbing stairs. So this is actually a dynamic programming problem. And um, yeah, so essentially what the problem is asking is that we're climbing a staircase and there are n amount of steps to climb to the top. And at every step, we have the option of climbing either one step or two steps, so we can skip a step in between. And essentially, we're supposed to return how many different ways we can climb to the top, so all the different combinations. So for example, let's look at example 2, where n is 3. So that means we have 3 steps, right? So we have step 1, step 2, and step 3. Now, basically, if we start at the bottom, we can see that we can climb up the staircase one step at a time. So we can climb it up here, here, and then here. And that is a very valid solution for this. And essentially, that's one way to climb to the top, where you take one step at a time. Now, another way we can climb the staircase is if we can skip uh, the first staircase. So we can actually take 2 steps, right? And then we can take another step here, and that's another valid way to solve this problem. And now the last way that we can climb up this staircase is if we actually do take the first step and then we skip 2 steps to climb to the top. So when n is 3, there are 3 different ways to climb to the top. Now to solve this problem using dynamic programming, we can actually use the tabulation method. And in tabulation, essentially, we create a table and we use the previous computations to get the next computation, right? So in our example, when n equals to 3, we can create a table, like a DP table. And in code, this would just be an array. But we can create a DP table that would be starting at 0 and then going all the way up to 3. So notice that in our DP table, the size or like the length of this DP table is actually like n plus 1, with n being 3, because we want to take into account 0, which is one of our base cases. So that's why the length is actually n plus 1. And we're going to implement this in code later on as well. Now in this example, we're gonna fill up the table bottom up, so in this case from left to right. And so our base case, so if we have 0 steps, that means there is one way to climb to the top, and that's essentially just by doing nothing, because you're already at the top, right? So essentially, if we have like 0 steps, right, we're just on this like flatland, we have 0 steps. So the way that we can actually reach to the top, we're already at the top. So there's only one way to do that, and that's why the base case at 0 is simply just 1. Now, for example, let's say we have just 1 step, right? And in this case, since we can take 1 step or 2 steps, we can only just take 1 step to the top, right? So there's only one way to climb one step, right? Now, this is where the magic of DP comes in. So for 2, rather than recursively computing 2 and breaking it down into more subproblems, we can just take the previous 2 elements of our DP table and add them together, right? So we can take the 1 that we have here and this other one that we have here, so at index 0 and index 1, and simply add them together to get 2. So 1 plus 1, that is 2. And then now when we get on to when the index is 3, so when we have 3 steps, we can just simply add the previous 2 elements. So in our case, this would just be 1 and 2. 1 plus 2 is 3. And this is just what we would return. And now the time complexity of this algorithm would be O of n, because we're just going to be iterating through the range of n. So when we're going to create this DP array and then just going to iterate through it once. So the time complexity of that would be O of n, and then the space complexity would be so there's actually two ways of solving this, and I'm going to solve it both ways. The first way is by creating a legit like DP table and going about it with that. So that's going to be O of n, but there is a different way of solving this by just using two variables and just initializing them and updating them as accordingly. And that space complexity would be O of 1. So in the next bit, I'm going to show the two different ways in solving this problem. So to solve this problem with the O of n time complexity and the O of n space complexity, so essentially first we can create our DP array. And we want to initialize the values to 0 at first because since we're just adding like the elements, if we have 0, it's a neutral value versus if we initialize it to like 1, that's gonna ruin the result. So, and then like I mentioned in the example, we want to set the length of it to be n plus 1. And then next, we simply just want to iterate through the DP array. So for I in range of the length of the DP array. And actually, before we do that, we have to make sure that we set our base cases. So here, basically, like I said in example, the base case of 0 would be 1, and then the base case of 1 would be also 1. And then we're going to be iterating through the length of the DP array, and then basically we want to start actually at index 2 and go all the way to the length because we already set the base cases for DP of 0 and DP in 1, so we want to start at the next element when we're iterating through. So then you have DP of I, which is just going to be I minus 1, so that's the previous element, plus the second previous element. So that's DP of I minus 2. And then after we're done iterating through that loop, we just want to return the last element, so DP of n in the array. And then that should be our solution. And just like that, it works. So this is actually like O of n memory complexity. So there is actually a way to do this without taking up extra memory. And the way that we can do that is we can initialize 2 pointers. So we can have 1 and 2. And we can both initialize them to actually 1. And then we can then iterate through it's going to be the same for loop, and we can iterate through essentially what would be iterating through like the DP array. So then iterate through 2 all the way to n plus 1 non-inclusive, right? And then here, what we want to do is we want to essentially set 1 to 2, and then you want to get the next value and set 2 to the next value. So essentially, like the next value would be 1 plus 2. And then we want to set 1 to 2 because we're iterating through, because like the pointers, we're like iterating the first pointer to be the second pointer. And then the 2 value is just going to be the next value. And then lastly, we just want to return 2. And this should work, yes. Yeah, and just like that, it passed all the test cases. So the time complexity of this solution is O of n, and the memory complexity is actually O of 1 because we're just using these variables. So I hope you guys found this video to be really helpful, and if you did, please like and subscribe. And if you have any more problems that you would like me to cover, please leave them in the comment section below. All right, have a nice day.